40,000 years from now, a tiny metal object built by human hands will silently glide past a dying star, and no one will be watching. No screens, no mission control, no signal, just a golden disk drifting alone through the dark, carrying the sound of a mother's heartbeat and the last notes of Beethoven into a universe that may have already forgotten we existed. That moment, that silent, lonely flyby, is the most haunting thing humanity has ever set in motion. And I'm going to take you all the way there. But not yet. First, quick question, where in the world are you watching this right now? Drop your country in the comments. I want to see how far this reaches. Now, let's go back to the beginning. Most people think the Voyager story ends the moment the signal dies. The last beep, the last blip on a screen somewhere in Pasadena, and then nothing. Mission over. Close the book. That is completely wrong. In fact, the moment the signal dies is the moment the real story begins, because these two probes, Voyager 1 and Voyager 2, are not stopping. They will never stop. There is nothing out there to slow them down. No friction, no air, no drag, just pure, uninterrupted momentum, carrying them forward at over 38,000 miles per hour, forever. Let's talk about where they are right now. You've probably seen the headlines, Voyager enters interstellar space. And yes, technically that's true. Both probes have crossed the heliopause, the outer boundary of the solar wind, the invisible magnetic bubble our sun breathes out into space. Voyager 1 crossed it in 2012, Voyager 2 in 2018. But here's what the headlines don't tell you. In terms of gravity, in terms of truly leaving our solar system, they haven't gone anywhere yet. Not really. Because surrounding our sun, like an enormous frozen shell, is the Oort cloud, a vast, distant sphere of trillions of icy objects, comets frozen in time, relics from the birth of our solar system. It is so massive, so unimaginably wide, that the Voyagers won't even reach its inner edge for another 300 years. And once they get there, it will take them another 30,000 years to cross it completely. 30,000 years. The entire span of recorded human civilization, from the first cave paintings to smartphones to everything you've ever known, fits inside roughly 15,000 years. The Voyagers will spend twice that time just quietly drifting through the frozen outer edges of our own backyard. During all of that time, they'll be perfectly preserved. No oxygen means no rust. No atmosphere means no erosion. The vacuum of space is the most perfect storage container that has ever existed. Aside from the occasional micro-collision with a drifting grain of cosmic dust, they will look almost exactly the same as the day they launched in 1977. Silent, intact, waiting. Now let's fast forward, way forward. We're done counting in years. We're done counting in centuries. We're counting in tens of thousands of years now. And the universe is finally about to do something dramatic. 40,000 years from now, Voyager 1 will no longer be completely alone. A star will come to meet it. The star is called Gliese 445. It's a red dwarf, small, dim, and ancient, located in a constellation we call Camelopardalis, the giraffe. On its own, it's unremarkable. You'd never find it with your naked eye. But Gliese 445 is moving toward our solar system right now, and 40,000 years from now, it and Voyager 1 will share the same corner of the galaxy. Not a collision, not even close. In cosmic terms, Voyager 1 will pass about 1.6 light years from the star. That's still trillions of kilometers. But in galactic terms, in the vast, incomprehensible emptiness of interstellar space, that is almost a brushing of shoulders. If there were something orbiting Gliese 445, a planet, a moon, anything with eyes, and if those eyes were powerful enough, they might be able to detect it, a small, cold, metallic speck crossing through the outskirts of their sky. a visitor with no voice, a probe that no civilization is tracking anymore. And then it would be gone. Voyager 2 has its own encounter, also at the 40,000-year mark. It will pass about 1.7 light-years from a star called Ross 248. Now here is where it gets genuinely strange. Ross 248 is not staying where it is. It is hurtling through space, and around 33,000 years from now, it will actually overtake Proxima Centauri, our current closest stellar neighbor, and briefly become the nearest star to our sun. Think about that. Voyager 2, launched from Earth in 1977, will fly through the outskirts of what will temporarily be our closest stellar neighbor at almost exactly the moment that star claims that title. That is not a coincidence you could engineer. That is just the raw, indifferent poetry of orbital mechanics playing out over geological time. But we're not done. Skip ahead again, way further this time. 296,000 years from now, roughly 3 times longer than modern humans have existed on Earth, Voyager 2 will pass within about 4 light-years from the brightest star in our entire night sky, Sirius. You know Sirius. On a clear night, it burns like a blue-white diamond low on the horizon. It is the star ancient Egyptians used to track the flooding of the Nile. It is brilliant, massive, and twice the size of our sun. And nearly 300,000 years from now, Voyager 2 will drift silently through its distant neighborhood, bathed in that fierce blue light, with no one aboard to notice. By then, and this is the part that should stop you in your tracks, by then, the Earth as we know it may be unrecognizable. Continents will have shifted, the coastlines on every map will be gone, the mountain ranges you've seen in photos may have eroded into plains. Whatever humanity has become or hasn't become will be separated from us by a gulf of time longer than the existence of our entire species. And yet, there it is, still moving, still carrying that golden disk. Now, here is the moment I promised you at the start, the thing that makes all of this genuinely haunting. The Voyagers will never escape the Milky Way. They don't have the speed for it. Instead, they will fall into a slow, enormous orbit around the galactic center, around the supermassive black hole at the heart of our galaxy. One full loop will take somewhere between 225 and 250 million years. They will become permanent citizens of the Milky Way. They will pass through spiral arms. They will drift through clouds of interstellar gas. They will witness the birth and death of stars that don't even exist yet. And 4 to 5 billion years from now, when our own sun begins to swell and die, when it expands into a red giant and swallows Mercury, Venus, and finally Earth itself, the Voyagers will still be out there, still moving, still intact. At that point, they may be the only proof we ever existed, because everything else will be gone. Every building, every city, every hard drive, every monument, every book, every painting, every recorded word. Plate tectonics will have ground our civilization into dust billions of years before the sun even gets there. There will be nothing left of us on Earth, except the golden record. That copper disc, plated with gold, bolted to the side of each probe, contains sounds of rain, whale songs, a human heartbeat, music from Bach and Beethoven and Chuck Berry, greetings in 55 languages, and 115 images of what we looked like and how we lived. Scientists estimate it will remain readable for at least 1 billion years, possibly 5 billion. The lifespan of the golden record may actually outlast the planet it came from. So when Voyager 1 made that silent flyby of Gliese 445 40,000 years from now, that image I gave you at the very beginning, that metal object drifting past a dying red dwarf star with no one watching, it won't be a failure. It won't be a tragedy. It will be a library. Still open, still waiting. Somewhere out in the dark, our music is still playing, frozen in gold, patient, eternal. If you made it this far, you just traveled 40,000 years and back. Share this with someone who needs to hear it, and drop your country below. I want to know where in the world this found you.